Good morning, good afternoon, good evening to everyone joining us today as Cambridge Technology presents why enterprises need to migrate to platforms that support event-driven architecture. Your presenters today, myself, Peter Buckley. I'm responsible for sales at Cambridge Technology, and Padmanabha Debnath, we call him Deb, who's our Director of Technology and our streaming guru. So thank you for joining us. And today will be probably about 30 minutes. Shouldn't take too long. The agenda is we're going to tell you a little bit about what event streaming is, how Apache Kafka works, integrating Apache Kafka, Apache Kafka and IoT data integration, and then introducing the Confluent Cloud. Just a little bit about Cambridge. We've been around since 1999, about 450 plus employees globally. As you can see, 400 or so in India, 50 in the US, and 50 in Germany. We have various locations across the US, Germany, and India. We provide a full suite of consulting services to our customers, from application development, big data, data warehouses, data lakes, AI, machine learning, IoT, cloud strategy, migration, cloud management, enterprise mobility, infrastructure management services, and we have a DevOps practice. As you can see, we hold several certifications: CMMI Service Level 5, ISO 27001, ISO 20000-1, and we're an AWS APN Advanced Tier partner, and we're a Confluent Focus partner for the Southeast in the United States. Next one, Rios. We work with various technology partners that add value to our customers and to our service offerings. Obviously, we're going to talk a bit about Confluent and Confluent Cloud later today on event streaming, but we are partners with Apika, OutSystems, CA, New Relic, Atlassian, Tableau. We are a partner with virtually all major public cloud providers: Amazon, Microsoft, Google Cloud Platform, and Oracle. And we maintain these relationships. On top of that, we've achieved a number of competencies, and we're members of certified programs within Amazon. We have a big data competency, Oracle competency, and we have a DevOps competency. We're a managed services partner, a channel reseller, a marketplace consulting partner, a solutions provider, and we're a well-architected partner. We've been working with Amazon since 2009. And at this point, I am going to turn it over to Deb. He will take you through Apache Kafka, and we'll have a section for question and answer at the end. Put it in the question box in the dashboard on the right, down near the bottom. There's a section for questions. Just type it in there. We hope you enjoy it, and I'll be back with you in about 30 minutes. Thanks, Deb. All yours.
Thank you very much, Peter, for the introduction. So today's topic, as Peter was mentioning, is about why enterprises need to migrate to event-driven architecture. Now, before we put in the use case for Apache Kafka, introduce Confluent Cloud, and see how you can integrate Kafka into your environment, it's very important to start with by giving a brief introduction about what event streaming really is all about. Next slide. Moving on. Now, when we talk about data integration, there are two ways. Traditionally, the ETL-based approach of data integration, where enterprises have built data warehouses, data mart, use Hadoop, and they run MapReduce jobs to crunch huge volumes of data, historical data primarily. And this model is very, very scalable. It allows for high throughput. It is durable, persistent. It allows for ordering of the data, retains the order. But typically, these kind of processing, it's batch driven. They are very, very time consuming. They're expensive. We get reports most likely the next day or at the close of business. But honestly speaking, in today's world, there is no real close of business for a 24/7 business. It's business all the time. There are events, there are things which happen for which we need to know about it immediately instead of the close of business or the following day. So these are the disadvantages with this kind of a model. And looking at the other end of the spectrum, we have the real-time driven messaging system. This model, of course, the advantage is it's real time, but it's not scalable. We have a fixed set of, it's typically a queuing based system or a pub sub based system. It doesn't scale well. Once the messages are read from a queue, it's gone. There's no persistence. There's no way to go back and replay the data. Once we make some code fixes or bug fixes, it's not possible to run through the earlier set of events or earlier set of data. Moving on. Now, what if we have the best of both the worlds we just spoke about? What if we have something which is highly scalable, durable, persistent, ordered from the ETL Hadoop based paradigm? And what if we can do it in real time from the pub sub based messaging paradigm? And merging both these concepts, we have something which is called event streaming, or the ability to see and process data as a continuous stream of events. This is very important in several lines of business today, where we have high volumes of data, whether it's LinkedIn, Facebook, Airbnb. Talk about any big enterprises which deal with a high velocity of data coming in and have the ability to process data in real time, and also have a system which is durable, persistent, scalable, and ordered. Moving on. So event streaming, it enables new outcomes. Here in this slide, we see the auto or the transport industry without event streaming, where one has to call and check for the driver's availability. There is no knowledge, there's no ETA for the driver arrival, no data on future usage. But with event streaming, we get a real-time driver-rider match, real-time ETA, and real-time sensor diagnostics. It can pretty much be applied in other any kind of industry, for example, banking, retail. Instead of nightly account balance updates, fraud checks, we get real-time updates and checks. And these have to be real-time. There's no point having a fraud check which is nightly or which is batch-driven. In retail, batch point of sale or no upsell through personalization, these are removed with real-time inventory, real-time recommendations, real-time sales reporting, and other features. Now that we have an idea of what event streaming is, let's introduce Apache Kafka, and let's see how Apache Kafka works. Moving on. What is Apache Kafka? Well, it started at LinkedIn. It's now an open source Apache project with a broad range of deployment. It is a messaging system, a storage system, as well as a stream processing system, all the three merged into one. Messaging system, it allows for pub sub to a stream of records. It's a storage system, it writes records to disk and replicate for fault tolerance. And it's a streaming system, it allows for stream processing or data as a stream of events, which we saw earlier. We will see how Apache Kafka allows for building streaming applications or streaming data pipelines. Kafka typically runs as a cluster, which is typically 3 or more, which stores stream of records in topics. Topics are nothing but categories. We'll see more about what a topic is in the subsequent slides. Topic is maintained in a distributed commit log or partitioned log. A topic is partitioned. There are 4 core APIs, producer, consumer, as the name suggests, they deal with producing data to a topic, and consumer that deals with consuming data from a set of topics that consumer is subscribed to. There is the connector APIs, which are reusable components to integrate with different kinds of systems. We have, for example, one could have a JDBC connector to talk to any kind of relational database. One could have a Salesforce connector. One could have a RabbitMQ connector. One could have Oracle CDC or Golden Gate connector. Talk about any system, there are probably open source or commercially available connectors already available for you to connect to these as source systems or as sync systems or destination systems. And then it's not just enough to be able to produce, consume, and be able to use connectors. There's a fourth API, which is called streaming API, which is really important when we talk about event streaming or have the ability to write streaming applications which deal with continuous stream of events. That's what the streaming API does. Kafka, it supports both real-time as well as batch analytics. It combines storage subscription to build real-time streaming applications and streaming data pipelines. For batch processing, the consuming application can actually process or replay the entire stream history, which is persisted on disk. To define Kafka, this is a good way of defining it. It's actually a message bus optimized for high ingress data streams, event-based data flows, and replay. Moving on. Now, the motivation for Apache Kafka, when we talk about data integration, we could have n number of silos which are dealing with a pair of source and sync systems, so a source system and a destination system. We could have custom written ETL code, which becomes very, very unmanageable and difficult to maintain over a period of time. They start out in a very simple way in most organizations or enterprises, but inevitably they become unmanageable because more and more source and sync systems start getting added. The ETL requirements keep changing, and the code base becomes very, very difficult to manage and maintain. There is no uniform or a single way of handling high ingress data flows, or different kinds of source and sync systems have a standardized ETL process and mechanism in place. So that's where the motivation for having a platform like Apache Kafka started, and it was conceived. Moving on. Look at the architecture, a fairly simple representation of the architecture where we have input systems. It could be any kind of systems: log aggregation, metrics, KPIs, audit trails, user logs, web logs, and output systems on the right. They could be any kind of analytical or reporting dashboard, BI dashboard, a search system, machine learning databases. It could be anything pretty much. And we have producers which deal with producing data, sending it to topics in the Kafka cluster. And we have consumers which consume the data from these topics. And there could be any kind of transformation involved in between and send it to the output systems. Zookeeper is an essential part of the Kafka ecosystem. It enables manages the core dependency. There are several things which are not a part of Apache Kafka core, which is Avro, Kafka Streams, and Kafka Connect. And as a part of Apache Kafka core, we do have several, we have the servers or the brokers, as they call it in the Kafka lingo. There are scripts to start and stop. There are utilities to create topics. There are command line producers and consumer tools to basically create data, publish to topics, consume data from topics, and so on and so forth. Moving on. A few fundamentals or definitions. Topics, as I was saying, it's the particular category to which a stream of records or messages is being published. Data is stored in topics. Topics are all typically split into partitions, and these partitions are usually in different servers or brokers. For each topic, Kafka keeps a minimum of one partition, and each partition which contains the records has an immutable ordered sequence. So the sequence is always retained inside a partition. For messages or records which are produced later would have a higher offset as compared to a message which arrived earlier in that particular partition. Partition is topics may have many partitions, so it can handle an arbitrary amount of data. It's a convenient way of not being restricted by the size or the disk space of a particular server. The concept of partition actually allows it to scale out. Offset is a unique sequence ID given to a particular record or a message in a partition. Replicas are nothing but backups of partition. Replicas are never read or they're never written into. They're just used for preventing data loss. Brokers are the different servers in the Kafka cluster. If there are n partitions in a topic and a number of brokers, each broker will receive one partition. The Kafka cluster has having more than one broker is called a Kafka cluster. It can be expanded without any downtime. Moving on. Producers and consumers, as I already spoke about, producers deal with publishing records to one or more Kafka topics. They send data to Kafka brokers. Consumers, they read data from brokers, and consumers subscribe to one or more topics and consume the published messages by pulling the data from the brokers. There's a concept of a leader replica and a follower replica. The leader is the node where all the read and write happens for a given partition. Each partition has one server which acts as a leader, and the followers could be n number of nodes which are basically replicas or copies of this particular leader. If the leader goes down, one of the followers gets elected as the next leader. Zookeeper, it's used for managing and coordinating the Kafka broker. Moving on. This is one of my favorite visual representation of the Kafka core system. From the top left, if we see, it's producer, it sends a record or a message to one topic at a time. A topic has 0 or more producers. A consumer subscribes to one or more topics. A consumer belongs to a consumer group. Now, what is a consumer group? Kafka introduces the concept of parallelism with the introduction of this concept of consumer groups. There could be any number of consumer inside a consumer group. Each of these consumers in a consumer group basically read or process different partitions. And at the same time, we cannot have more consumer groups than the number of partitions, obviously, for a particular topic. So the concept of parallelism is introduced in Kafka with this introduction of consumer group. We have partition. A topic is replicated over one or more partition, and a consumer pulls messages from 0 or more partition. We have replica, which it's a partition has one leader and 0 or more follower replicas. And at the bottom left, if we see, we have broker and a cluster. A cluster is made up of one or more brokers, and the replica is obviously in one broker. Moving on. Now, the power of Kafka. Why is Kafka so important? If we talk about, let's go back to what I was what I started talking about when we introduced both the models, the ETL or the Hadoop based approach, and then we had the messaging approach. So HDFS, or a distributed file system, it allows for storing files for batch processing, as we all know. A traditional enterprise messaging system, on the other hand, allows processing for future messages that will arrive after we subscribe. So one is dealing with a huge volume of historical data. The messaging system, on the other hand, is dealing with future data. But Kafka combines both these capabilities. By combining storage and low latency subscription, streaming applications can treat both past and future data in the same way. What I'm trying to say is, let's assume I have a streaming application or a single application which is processing historical data, stored data, but rather than stopping or ending when I reach the end of the data, it continues to process future data as it arrives. So I do not have to have two models or two different applications to deal with historical and future data. With Kafka, I can do both at the same time, and that's the power and the beauty of Kafka. And that's what we're trying to showcase in this particular slide, where Kafka is becoming, it's actually the de facto standard when we talk about event-driven or real-time event streaming, or having a streaming application or a streaming data pipeline. Kafka is the standard, and that there's no other system which can come close to what Kafka has to offer. It's real-time, it's reliable, scalable, it's persistent. trillion, a few of the data on the right, 2 trillion messages a day is processed at LinkedIn. 500 billion events a day is processed at LinkedIn, and more than a third of Fortune 500 companies are already using Kafka in some form or the other. Moving on. Now, how do you, so far so good, so how do you actually go about integrating Apache Kafka into your environment? That's what we'll talk about in this section, the next few slides. Moving on. Spaghetti. This is what we have, or we had when we did not have Kafka. Different lines of business, different source and target systems, all kinds of custom-based ETL code, data integration code, and it's a mess, as we see. As we try to integrate more and more systems, the mess is going to become messier. Now, moving on, when we introduce Kafka, we can streamline this, the ugly picture which we saw, into a process-oriented, beautiful thing, systematic thing, where we have any kind of context or contextual event-driven application. We have Kafka in the center with its core producer consumer streaming and connect APIs, and we could be sending in or processing data from any source or sync systems and building event-driven applications out of it. So we have a streamlined way of handling event streaming or data which is highly event-driven. Moving on. What is Confluent? Many people in this audience may or may not have heard about it. Confluent was founded in 2014 by the original creators of Apache Kafka. It's a technology which was developed while at LinkedIn, like I was telling you earlier. That's where Kafka was born. It's the largest contributor of Apache Kafka. Over 1/3 of Fortune 500 companies use Kafka in production. 6 out of 10 companies process 1 million plus messages daily through Kafka. Moving on. I'll tell you why we introduced Confluent, because Confluent is pretty much the most standard, one of the best ways of running Apache Kafka. Now with Confluent, I have the option of going with self-managed software where we manage the entire Confluent platform, or we could go with Confluent Cloud. It's a fully managed service. It's Apache Kafka re-engineered for the cloud. It's available on the leading public cloud providers, AWS, GCP, and Azure. Moving on. Now here we'll see how Apache Kafka actually fits into the IoT space. Apache Kafka and Internet of Things. Whenever we talk about Internet of Things, most of the time we tend to think that it's all about devices and sensors. Well, of course, devices and sensors are the foundation in an IoT platform, but the core value which we get from an IoT platform is actually in the data, or the huge volume of data which is generated by these devices and sensors. Apache Kafka here comes in here and shines. It's actually a key pillar of a robust IoT data platform. It's designed to handle the massive or high ingress or high volume data which is generated in an IoT platform, and it easily allows us to handle massive amounts of data ingestion. It acts as a gateway to the data processing pipeline for storage, transformation, processing, querying, and analytics. Apache Kafka is a high performance ingestion layer for sensor data. Devices like heating, ventilation, ACs, they send data to a central IoT gateway, which then pushes data to the Kafka cluster. And then there are lots of ways to handle data which is available in the Kafka cluster. Metrics like temperature, humidity, air quality, they go through a hot path. By hot path, what I'm trying to say is they need real-time processing. We need to do something in real time with these metrics. And then there are metrics like load or power consumption, which are collected and analyzed over a period of time. They can go through the cold path, or they can go through a batch processing process like Hadoop and MapReduce. Kafka is not a replacement for message queuing over telemetric transport. People who have worked with IoT know about what MQTT is about. It's a machine-to-machine protocol which is optimized for high latency or unreliable networks. Wherever we have devices or mobiles where the network is not really reliable, that's where MQTT protocol really shines for machine-to-machine communication. But it cannot handle high velocity, or it cannot really ingest data which is coming in at high velocity, where we saw Apache Kafka really shines. So the roles of Kafka and MQTT are really very different. Kafka versus HTTP REST. Kafka now uses a binary protocol over TCP, although there's a REST proxy from Confluent, which is basically a REST based way for sending data into a Kafka cluster, but that is not the fastest way. To get the best performance, one should use a native client library. Kafka is written in Java, so the fastest way would be to use the Kafka client library for Java instead of HTTP proxy. There are client libraries also available for C#, Go, Python, and a few other languages. We could use those client libraries also to send Kafka and get the best performance out of Kafka, because Kafka uses a binary protocol over TCP. Now moving on. Whatever I just spoke about, a visual representation of different devices which are sending data to the IoT gateway. The gateway then sends the data to the Kafka cluster, and from there it could take two paths: the hot path for metrics like temperature, humidity, which we saw, and then the cold path for metrics which are captured over a period of time, which can go through Hadoop or MapReduce based processing. And for real-time analytics, we could use Spark or Apache Storm or any other tools which are meant for real-time processing of high ingress data. Moving on. Now we'll talk about, the next few minutes, we'll talk about the Confluent Cloud and why it is a fully managed Kafka re-engineered for the cloud, or fully managed Kafka as a service. Moving on. Why do we really need Kafka as a fully managed service? So that we can deploy it in minutes. We eliminate the operational burden. Obviously, we ensure minimal SLAs, and we integrate with cloud services. The four primary goals with why anybody or an organization would go for Kafka as a fully managed service. Moving on. So different components, the black layer at the bottom, it's the open source components: Apache Kafka core, continuous commit log, Kafka streams, Kafka Connect APIs, cloud native, elastic scaling, usage-based billing, that's the Confluent Cloud self-service. If we go for fully managed Confluent Cloud or the Confluent Cloud Enterprise, we have the replicator, which is the product which we see on the top. This allows for replicating across Kafka clusters in multiple data centers, or if we talk about a cloud, different regions of the public cloud. The community licensed offerings are fully managed schema registry, KSQL, REST proxy, and connectors. And then we have security, compliance, SLAs, enterprise ready, unlimited scale, which are different offerings with which from the Confluent Cloud Enterprise offering. Moving on. Most Kafka as a service are partially managed. So why do we need Confluent Cloud, and what does fully managed mean? Infrastructure as a service, where it automatically takes care of upgrades, batching, maintenance. Kafka specific management like data balancing or rebalancing, sizing, retention, latency, throughput, performance, Kafka bugs, uptime monitoring, recovery support. All these are automatically taken care of. And scaling, scale the cluster as needed, data balancing the cluster as nodes are added. It's future proof and evolve as you need. Support for any Kafka issue with less than 60 minutes response time. So these are the offerings of the Confluent Cloud Enterprise. Moving on. So the two flavors, which I already spoke about briefly, the Confluent Enterprise Cloud and the Confluent Cloud, 24/7 gold support with 99.95% uptime. It supports multiple availability zones and VPC peering also. So if these are your requirement, then you would go with the Confluent Enterprise Cloud, or if these are not really a big deal, then one could try just the Confluent Cloud edition. It's community based. Moving on. Cloud native agility, scaling elastically, having the ability to do that from 0 to 100 MB per second. No need to size or provision clusters or manage them. Consumption-based pricing, only pay for what you actually stream. There is no minimum. Scale to tens of gigabytes with our enterprise plan. And it has fully managed schema registries, S3 sync connector, and KSQL. KSQL, of course, is still in preview, and it's not recommended for production yet. Moving on. The Confluent Cloud Enterprise, how it performs at a GBPS scale. Just a brief snippet of the latency, 3 days to get it up and running, unlimited throughput and fan out, and infinite retention. Moving on. High availability for mission critical apps. We could deploy it in multiple availability zones. This diagram is specific to AWS, but this holds good with GCP or Azure cloud as well, where I could have a dedicated Kafka cluster in a VPC and spread it over 3 availability zones with 3 times replication and get a guaranteed 99.95% uptime SLA. Moving on. Confluent Cloud, it allows us to run mission critical enterprise applications with 99.95% SLA, enterprise grade security compliance. One can do more with Apache Kafka. Like I was saying, we have fully managed schema registry, KSQL, and connectors, although KSQL is still in preview, and stream across hybrid and multi-clouds. It's a bridge, way of bridging the on-premise to cloud with hybrid Kafka. We could have a Kafka cluster on-premise and a Kafka cluster in AWS or GCP, and use the Confluent Replicator product to replicate the data across both these clusters. Moving on. Now, the next generation Kafka and what we can expect from the next generation Kafka. There are essentially 4 parts to Kafka Next. Essentially simplifying Kafka to make it more appealing to long-tail messaging users who are still using Redis or most recently NATS. Removing Zookeeper is a part of this effort. There's a lot of community push to remove Zookeeper and remove the dependency with Zookeeper basically for Kafka. Enabling multi-tenancy, isolation, and ability to set quotas, security to tenants who can safely share the same cluster. Enabling instant scaling of a Kafka cluster that takes hours at times today, and increasing the capacity of a Kafka cluster to support millions of partitions. Truly enabling global deployment of a Kafka cluster across wide area networks while supporting disaster recovery and geo affinity and awareness. So these are the things which we can expect from the next generation Kafka. So stay tuned for that. With this, I come to an end for this particular webinar, why enterprises need to migrate to event-driven architecture. Thank you everybody for taking out the time today to join this webinar. I now hand it over for Q&A. Thank you very much.